It's time for a new unit, so we're starting the linear relations unit in math with McComish today. And we're going to be looking at some expressions. An expression in math is a statement showing a pattern or how something is related using numbers and a variable. So yes, we have to use letters in this unit. So 5k plus 2 is an example of an algebraic expression. It's called an expression and not an equation because it does not have an equal sign. So that is the difference between those. Now you need to know a few terms. So a numerical coefficient is the number in front of a variable. So 5 is the numerical coefficient in this expression. And what this says is 5 multiplied by whatever k is. So that's k is our unknown or our variable. Could be our changing amount. And then the next term is a constant term. It's a term that's just a number without a variable. So 2 is the constant term, so plus 2. So I could ask you, like, if k equaled 3, what would be the value of that expression? So I could say it's 5 times 3, which is 15, plus 2, so that expression would equal 17 if k was 3. So when writing an expression, we're going to find the unknown or changing amount and give it a letter variable. Then we're going to find out maybe what the coefficient would be for that variable and constant, or how is it changing. And also find out what the constant would be. Okay, the unchanging amount that's the same every single time. And then just write the entire expression. So we're just going to do some examples to practice this. A number divided by 5 and then add 2. So we're going to write an expression for this. So a number, that's what we don't know, what that number is. So that's going to be our variable. Okay, let's say it's n. Now it says to divide it by 5 and then add 2. So that is actually my expression. A number divided by 5 plus 2. So the numerical coefficient, well, it's kind of 1/5 on that one. The constant plus 2. If that number happened to be 10, if n equal 10, what's the value of the expression? Well, instead of n, I put in 10, so 10 divided by 5 is 2, plus another 2, so that would be 4. Okay, let's say Brady is baling hay in the summer. He thinks he can make 120 bales per hour. Write an expression to relate how many bales in total there will be. Well, what that depends on is how long he bales for. I mean, it depends on a lot of things, but saying that he goes 120 bales per hour, then the number of hours he bales for will show how many bales he gets. So let's say that's H, number of hours he bales. Well, if he bales 120 per hour, we're going to take our number of hours and times it by 120. It becomes a numerical coefficient. Now we put it in front of the letter. So it's 128, which means 120 times however many hours he bales for. And that's the expression to find the total number of bales. Now, how would this change if we said he had 40 bales in the field to begin with? Well, that would be our constant. So it's still 120 bales times an hour. But we started with 40 bales in the field, so we have to add those on as the constant. Let's say Autumn is going to join figure skating again. She has to pay an upfront fee of $175 to join, plus $25 for every hour of ice time she uses. Write an expression to relate how much it will cost her to how many hours she skates. So again, it depends on how many hours she skates. So let's use H for our variable. Okay, so it's $175 just to join. Okay, so that's a constant. It doesn't matter how much she skates. If she joins, she has to pay that $175. Okay, so let's say $175 plus $25 per hour. So if you times $25, however many hours she works, you'd find out how much, or for how long she skates. So that would be my expression. 175 is my constant, plus $25 per hour. So you could figure it out. If, let's say you wanted to know if she skates 10 hours. So you go 175 plus 25 times 10, which would be 250 plus 175, which would give you $425. So that's the kind of expression you can write and then use it to answer different questions. Let's say a baker starts with 200 donuts. He's going to sell them. He sells an average 35 donuts per hour. Write an expression to relate how many donuts he has left compared to how many hours he sells for. Well, let's just make hours X this time, because often in math we use X and Y for variables. So he starts with 200 donuts. That's a starting point. He sells 35 per hour. So if I did 35 times however many hours he sells, I find out how many, but I want to know how many he has left. So I'm going to subtract 35 times however many hours he sells. And that will show how many donuts he has left compared to how many hours he sold donuts for. Okay, you can also do terms or relations with patterns. So I would want to create a table of values. Term number and blocks. So for this one, term number 1, I have 3 blocks. 2 is 6, 3, 9, and so forth. So to find this, okay, I'm increasing by 3's each time. So all I have to do really is multiply by the term number by 3, no matter how many terms. So if my term number was t, my pattern or my expression would be 3t, or 3 multiplied by the term number. Okay, let's do this example with trees. Okay, so this is picture number 1, 2, 3. Now if you notice, the black tree is remaining the same. That's going to be our constant. Okay, so if I did a table of values and did picture number and then number of trees, so 1, 2, 3, I have 3 trees in this one, 5, 7, and the pattern would continue. So every time I'm increasing by 2 trees. So for every picture number, I could times the picture number by 2, since I'm increasing by 2. But I have a constant. This tree is remaining the same, just 1 tree. So I would have to add 1 to that. So if picture number was P, to find how many trees I would have in that, it would be 2 times the picture number plus 1. And that would be my expression that I would use. So that just shows some examples of linear relations and how to write expressions.